Hello there, this is our third and I'm hoping final lesson on transformations. We're looking at a very particular type of transformations. So we're looking at reciprocal functions. Reciprocal functions of normal type algebraic expressions where, for instance, 1 over x is one graph. And this 1 over x graph, I think I've mentioned this before actually, as being a graph that you should know. So notice it's in two parts. These two parts don't join. So some people, GCSE, I know, tend to try to draw these two together and sort of draw an imaginary line here. They don't, so don't try. So this is y equals x. It's called the standard reciprocal graph. You might recall, for instance, a reciprocal of 5 is at GCSE you got taught it was 1 over 5. So notice that here the reciprocal graph is y equals 1 over x. This is the graph you need to know. Two parts. And this y equals 1 over x squared, also reciprocal, but it's a reciprocal of the squared function x squared. Now x squared is obviously a U shape, and this is very much not a U shape. But I've had people describe this as a pair of curtains in the past, so I've written it here just to let you know how warped some of my previous students have been. They reckon that looks like, well, I suppose they do vaguely look like curtains, or maybe some kind of column, but one way or the other, you need to know what that graph looks like. So, bearing that in mind, a reminder of what we saw last time. You should have copied all this down. These are the rules, if you like, for translation stretches and reflections, either in the bracket or not in the bracket, depending on which one you've got. And remember, if it is in the bracket, it basically is going to do something left and right rather than up and down. If it's outside the bracket, 2 of x, for instance, it will go up and down. But if it is in the bracket, not only will it be left and right, but the opposite happens to what you expect. So, f of x plus a, notice it went left, not right. You'd kind of think a plus would make it go right, but it doesn't. It goes left when it's inside the bracket. F of ax, you times in, so you kind of think times makes it goes bigger. Nope, not when it's in the bracket. Scale factor here is 1 over a, which is really saying it gets a times smaller. So just bear that in mind. Anyway, sketch the graphs time. So sketch the graph of y equals 1 over x. Well, I've just shown you what that looks like. I can do that quite easily. Oh, it says on the same axis. Do what it says. So you're meant to know that this is 1 over x. Okay, that's 1 over x. So label your graph accordingly. Y equals 1 over x. And y equals 3 over x. Now just bear in mind that that basically means 3 times by 1 over x. It is 3 times bigger. It is a stretch to make it bigger. So don't be surprised if I take any point, it'll be 3 times higher. If I take any point, it'll be 3 times higher. So in actual fact, the new graph looks very much like the last graph, but it's 3 times higher. Now, it doesn't have to be exactly 3 times higher. It's only a sketch, but it should be roughly. Now notice this, it goes 3 times lower in effect here. These kind of go forever and ever, but they'll never ever touch. They'll never even cross either. So this one here is y equals 3 over x. As part B, so it says describe the transformation. Well, neither you already did that. It's a stretch, posh terms, parallel. That goes up and down, so therefore it's the y-axis, but we write parallel to the y-axis. It's just the way we're expected to write it. By a scale factor. And the scale factor is 3, because it's 3 times bigger. So that's my answer. Let's see what it says. Stretched by a scale factor of 3, parallel to the y-axis. And that was the posh graph. Now, I haven't drawn it higher, but you can see, take any point. Take that point there, 1,1. Where does it go to? There you go, 1,3. 3 times higher. Take a point down at the bottom. I shall do this point here. That looks to me like -2, comma, -0.5. Of course it is. It's what 1 over x is. But notice now it's still -2. That point there. -2 across. But where is it? It looks like it's -1.5, or better written as -3 over 2. And that's 3 times that. You can see it's got 3 times lower. So yes, it worked. Sketch the graph of 1 over x squared. Okay, fair enough. That's easy enough. Just showing what that looks like. I expected the graph looks like vaguely like that, vaguely like that. It's not very symmetrical, is it? Hopefully yours is going to be better than mine. Yeah, just about get away with that. You should be wary actually about that. I should just do this because I know that I've seen exam questions where if you drew double lines you lost marks. So I deliberately then just went and got rid of it. Yeah, just about get rid of that. Yeah, sort that out. That's my y-axis. That's my x-axis. So this is y equals y over x squared. Write down the equation of the function after the graph has been translated by the vector -1 and -2. Alright. So what's it going to do? Oh, I just lost that there. What's it going to do is, as I say, it goes one left here, and it goes two down. Now that's in two parts, as I say. So the equation is going to, well, I've got to replace that x by, because it goes one left, I've got to replace it by, here's the weird thing, x plus 1. Notice how I've got rid of the x. I've made it x plus 1. Oh, don't forget the squared. So it went one left, so I want to say -1 is the obvious thing they'd put in it. But no, because it goes in the bracket, it goes the wrong way. So 1 over x plus 1 all squared. Oh, but there's also this 2 down. This makes it go 2 down. Now this is outside the bracket. So, and I'm allowed just to write -2. There you go, done. Sketch a new graph. Okay, sketch a new graph. What will it look like? I think it will be like that. But it's got to go one left and 2 down. So one left is probably best if I show that. That's -1 there. 2 down. That's there. So that is, now just bear in mind what this is. That's, if you like, this point here. That has gone there. So I think I need what I'm going to call asymptotes. Asymptotes are points through, lines through which the graph struggles to go through. Very often doesn't go through it at all. So it will get close to that, because the last one did. And it will go there, something like that. It's not a great graph, but there you go. And this is -1, and this is -2. Okay, let's see what the posh graphs look like. Oh, that's the first one. That's the correct equation. Let's see what the equation right, and there it is. And I say, if it was me, I'd just show this. Hitting, notice at -2, and this is at -1. There it is. Describe the transformations that transforms 1 over x squared to y equals a over x squared. Well, this is easy. It's just best thinking of this as equal to a times by 1 over x squared. When you see it like that, you think, oh, but it's just been multiplied. When you multiply something, it becomes a stretch. Is it in the bracket? No, it's on just outside of it, so it's parallel to the y-axis. And scale factor. Well, you just do what it says. No special tricks here. Scale factor equals a. Find the coordinates of the point of intersection of the graphs 1 over x and y equals a over x squared. Alright, now whenever you want to find the coordinates of points of intersection of two graphs, which say y equals this and y equals that, you can say this equals that. That's what we're going to do. We're going to say 1 over x equals a over x squared. Now it's not very nice this, because I've got a's. But that's what I've got to do really. So first thing I'm going to do is get rid of these fractions. So I'm going to cross multiply. And I'll get x squared is going to be times by the 1, which gives me x squared, equals, and that's x times that a, which is ax. Having done this, get them on one side. X squared minus ax equals nothing now on the right. Take x out as a common factor. Gives me x minus a. A lot of people here want to divide by x. Don't do that. You'll lose an answer if you do that. And therefore, when is this times this equals to 0? Well, x has to equal nothing, or x could equal a, because a minus that a would also be nothing. So there's my two x coordinates. Now it wants coordinates, so I think it wants y as well. So therefore 0, that's interesting. 1 divided by 0. Now 1 divided by 0, chuck it in your calculator. Error. So you can't get this. So the posh way of saying error is undefined. Ooh, what happened there? Undefined. And if that's, so that's not, I think that is not a point of intersection. I haven't got enough room to write that, but point of intersection. So I think this one is not an answer. I'm going to cross that one out. X equals A, I think is fine. So when I put that into here, I get A, comma, 1 over A as my point. State the equations of the asymptotes for these two graphs. Well, all right. Let's do this on the next one, perhaps. Or better not, because I've got the answer there. So y equals, it said 1 over x. So this has got two asymptotes. It's there and there. And the asymptotes, well, it's the x-axis and it's the y-axis. But it does say equations, and it doesn't sound like an equation if you write x-axis and y-axis. So I suppose I should write x-axis and just tell you that that is best known as y equals 0. Because anywhere along that line is equal to 0. And the y-axis is the other asymptote, and that is best known as x equals 0. The y equals a over x squared. Well, we know that this looks like this. And there's really only one asymptote. No, there are two asymptotes still. There's this one going across and this one up. It's exactly the same. So it's the same answer for both of them. Okay. And that's what they got. So, yep, we got that. We got that. Stretch parallel to the y-axis. Yes, we got that. And that's it. Exercise 5D is done. We'll do some questions in class and make sure your notes are good. Hope you are making good notes as we go through all these exercises. Make sure your notes are good, and we'll practice this in class. All the best.